Nature provides many outlets. You just need to know where to plug into.
In an industry where big things come in small packages, efficiency is key.
With a population this size, there's no way we can't innovate.
Life is fragile. One mistake can usually end one.
Possibilities are endless. We are only limited by our imagination.
Safety is the top concern. Energy production is next.
Chemical engineering. Since its humble beginnings in the field of glass blowing to the boom of the Industrial Revolution,
The profession has grown into a worldwide industry spanning more than 50 countries and thousands of companies and businesses.
Chemical engineers work closely with various fields in non-related sectors of society.
And the origins of chemical engineering in the different fields we know today may just surprise you.
Modern medicines that we have right now has its roots in ancient Greece. Years ago, the Greeks formed medical schools in order to cure diseases. In Asia, we have the Chinese to thank for our medicines. They were able to utilize herbs and spices to treat common diseases like colds and coughs.
Nuclear engineering came about in history after the discovery of nuclear fission in 1938 by a German, Otto Hahn. It really rose to prominence during World War II so that they could create a bomb, which the Americans were successful in making during Project Manhattan, and they used a nuclear bomb to effectively win and end World War II.
Colander, a US pool and billiard ball company, was looking for a replacement for ivory. John Hyatt proposed a cellulose derivative that was later patented under the name celluloid, and its success led the way for the development of other plastics.
through the years, the world has seen the exponential growth of human population. This resulted in the increased need for food, which is one of the most vital elements of the survival of mankind.
Fuel cells and batteries were first developed as an alternative for the internal combustion engine by the 1960s, and up to this date, fuel cells were successfully used in manned spaceflight in aerospace missions.
The first recorded uses of oil and gas date back to 1801 that scientists discovered that such resources were excellent fuels. This led to the first train powered by coal and eventually the first combustion engine.
So who plays key roles in chemical engineering?
One of the things that chemical engineers do in this field is, in the field of energy, they're the ones who help design and construct nuclear power plants that provide energy to consumers. They help regulate the cooling systems and other systems.
One example would be through the development of medical devices, like the kidney dialysis machine. These machines work by filtering out excess waste like salt in the blood.
Chemical engineers are responsible for the extraction and processing of crude oil and natural gas. They develop processes that separate the raw materials into its components to be used by different industries such as plastics, medicine, and food.
Engineers working in the field of plastics and innovative materials are mainly involved in process design. They make sure that the processes they make are efficient and economical.
Engineers play a vital role in developing the safety for the use of fuel cells. Chemical engineers are trying to find a way that can help safely deliver hydrogen to households and cars, the same way that there are gas stations.
Chemical engineers could be credited with the improved conversion of raw food into safe consumer products. Food processes such as milling, drying, refrigeration, extrusion, heat and mass transfer have seen great developments.
So, who plays key roles in chemical engineering?
After the oil boom in the 20th century, many companies came up like Chevron, ExxonMobil, and here in the Philippines, Petron. These major oil companies have invested majorly in alternative energy resources. Shell handles a solar-powered car competition that encourages students to design energy-efficient vehicles.
One of the companies that played a significant role in the field of pharmaceutical is Merck. They were the first company to produce a vaccine against measles, chickenpox, and even hepatitis B. When it comes to the Philippines, the biggest pharmaceutical company that we have is Unilever.
Governments are still one of the companies that really help in advancing nuclear engineering because they're the ones who run power plants.
Leo Baekeland invented the first completely synthetic plastic called Bakelite. Corning Incorporated was the company that invented Pyrex borosilicate glass, and DuPont was the company that invented Teflon.
As of now, the major companies that play a role in the development of fuel cell technology are the car companies such as Ford. So they're trying to incorporate the fuel cell technology into the engines of their cars.
You have the common brands you most likely see in your households such as Nestle and Kraft, which have greatly contributed in food packaging and the production of food with optimal nutritional value. You also have Pepsi and Coca-Cola, which are giants in the beverage industry.
With all these innovations and advancements, chemical engineering still has a long way to go.
Greed is probably one of the main reasons why we have problems right now. Take GlaxoSmithKline as an example. Last year, they were bribing doctors and hospitals just so they could sell their products at higher prices. Novartis was not able to declare the side effects of the leukemia drugs they were selling. There were 10 reported serious cases of severe side effects.
One of the problems that nuclear engineering faces, first of all, is danger. Like we've seen in Japan and Russia, some of the nuclear power plants, they failed, and so a lot of people died due to nuclear radiation and also because of longer lasting effects of the radiation. There's a social stigma that living beside or living nearby a nuclear power plant is very dangerous. Even though the Philippines has the facilities to run a nuclear power plant, the project never went off the ground.
One of the main problems the plastic industry is facing right now is waste management. This is mainly due to plastics taking too long to decompose. And the processes used to produce plastics often produce byproducts. And so now we have the problem of disposing plastic and its byproduct.
In making batteries, they require the use of rare earth metals. The Philippines isn't really that rich in these metals that are required for the development of batteries. There is no technology available that would make the use of hydrogen safe. We don't have a facility that can distribute hydrogen to cars the same way that they can distribute oil easily.
People's well-being should always be the number one concern of this field. However, when greed comes into play, the supposed top priority is greatly compromised. One of the companies which have been questioned regarding this matter is Nestle, who has been accused of profiting off the natural world with patents on breast milk and medicinal plants and the privatization of water. When you say that a certain product has an artificial ingredient, people tend to shy away from it. One of the companies that have received controversy regarding this matter was Kraft, who was compelled to remove tartrazine, a synthetic yellow dye, from their products like cheese and macaroni after a public petition.
One of the major problems with oil and gas are the carbon emissions and byproducts that damage the atmosphere. However, it costs a lot to maintain low carbon emissions. Many companies have been spending on government officials to have them ignore the amounts of toxic chemicals they're releasing into the atmosphere. A study found that oil companies in the US spend over $43 million during election period. We're also fast approaching peak oil. This is when the cost of extracting oil from reserves becomes too costly. As we approach this point in time, we have to begin acknowledging that fossil fuels are scarce and renewable energy is the future.
Greed,
Waste management.
Scarcity, danger,
and various social issues.
will we ever find the solution?
Once I do become a chemical engineer, cross fingers, I can help by devoting my time and skills. So maybe I can go to one of the pharmaceutical companies in the Philippines and just do my best as a chemical engineer. Just like what they say, it's the little things that count.
So as a future chemical engineer, I can help contribute to the development of nuclear engineering in the Philippines. Firstly, I think the most important one is trying to remove the social stigma that people have towards nuclear engineering. If handled very well and very carefully, there is no reason for nuclear energy to be nuclear engineering to be a danger to the people living around the area.
As a chemical engineer, I think one of the main contributions I can do is in the research design of biodegradable plastics. Why biodegradable plastics? Because as I said earlier, waste management of plastics has been a very, very big problem for the Philippines. And not just the Philippines, the whole world. So if biodegradable plastics really do become a thing, then it would really help with waste management, because that way we could put them in landfills and not worry about it not decomposing and causing problems in the land.
When I become a chemical engineer, I want to help address the issue about safety. Right now, the internal combustion engine produces too much pollution, so we have to find an energy source that would produce less pollution, and that is fuel cells. But there's a huge step back to fuel cell technologies as it poses safety issues. So by addressing safety issues, we can help incorporate fuel cells into the engines of our cars while producing less pollution and thus saving our environment.
Chemical engineers deal with unit processes and operations. With knowledge of that kind, I believe that we could create safer products with safer packaging using the least amount of resources. And that way we would be able to contribute to this field as chemical engineers.
When I become a chemical engineer, I hope to work closely with energy companies so that I'm able to help reduce or eliminate the amount of toxic byproducts. I also hope to help power the far-flung regions of our country so that they may have access to cheap, clean lighting and energy.
But what field should we tackle first in our country?
I believe that we are slowly embracing clean energy.
The Philippines, I think, really needs to prioritize first oil, gas, and renewable energy.
Oil, gas, and clean energy should be this country's top priority. If they say that we aren't ready for it, then we should make ourselves ready for it.
This is because I think they're the central industry. They hold the other industries together.
This is the backbone of all our other industries.
Because those are the forms of energy that already exist in the Philippines.
The Malampaya plant is projected to extract over 1 trillion cubic feet of natural gas toward developing the commercial gas industry in the Philippines.
There are many areas in the Philippines that are rich in these natural resources.
And there are also oil refineries and things like that. So the facilities are already there.
Without it, food, plastics, and medicine won't be produced.
Because it's not just that industry that will grow, but it will help the other industries grow too.
The Philippines will remain heavily dependent on energy imports, especially oil, at least until 2035. American Development Bank said in its study, Outlook 2030, Asia's Energy Challenges.
I think we need to just continue to try to be more efficient with the things that we are already doing to produce energy.
Focusing on oil, gas, and renewable energy actually helps the entire Philippines and its economy grow and prosper.
Chemical engineers know how to balance things. So this is a great thing on our part.
Also, with the death of this industry comes the death of transportation. This would lead to the death of the economy.
By maximizing these management on resources, our country can be globally competitive.
Chemical engineering, a profession in which a knowledge of the natural sciences is applied with judgment to develop economic ways of using materials and energy for the betterment of mankind.